In this video, we're going to go ahead and find the correlation between these two variables. We're going to look at the speed that a car is traveling and the fuel efficiency, or how much fuel it uses. So we have these different speeds and we have these different fuel efficiencies, and we're going to look at the linear correlation, the quadratic correlation, and the exponential regression equations. We're going to look at all three of these with this data. So our first step is to go ahead and go to our calculator, hit Stat, and edit, and we're going to put all of our variables in. In L1, we're going to put our explanatory variable, which is our speed, because it's the easiest one to measure. So we're going to try to see if by changing our speed, are we changing our fuel efficiency. And in L2, we're going to go ahead and put our response variables, the fuel efficiency. So we'll go ahead and enter that data into the calculator. And then we'll do our response variable, checking to make sure that our numbers are put in correctly, because if we put our numbers in incorrectly, then it's not going to do us any good doing these analysis, because it's going to just be the wrong data. So the calculator can't tell if the numbers you put in are correct or not. So now the next step, we can go ahead and Stat. We're going to calc, and we're going to do a linear regression, which is option 4 here. So we click enter. So we want our explanatory variable. We put that in L1, so that's our x, so that's good. So we can go down to the next one. L2 is our response variable, so we can leave that in L1. Frequency lists and stored regression equations we don't need for this data set, so we'll just leave them blank. So we'll go ahead and go down to calculate, and it gives us our equation, but it doesn't give us our r and our r squared value. So we can turn them on by going second, catalog, and scrolling down until we find where it says diagnostic on, which is right here, this option here. So we need to turn the diagnostic functions on, because by default they're off. So go ahead and select that option and press enter, and it'll say it's done. So it's done, it's turned them back on for us. So now we can go back to calc, go back to linear regression, and we can go ahead and calculate, and now it'll give us our r and our r squared terms. So our r is negative 0.04, which is a pretty weak correlation here. Now we don't need all these decimals, so I'm going to round the first number to 0.006 and this number to 29.9. So we have our linear regression equation, so we can go ahead and write that down for our first one. So now we can go ahead and go to Stat, go over to Calc, and now we're going to do a quadratic regression. So we go to a quadratic regression. Everything's the same as the linear regression. All the inputs are the same. So we'll just go ahead and go down to Calculate, and our diagnostic is still on, so it's calculating out our r squared, which in this case is 0.9, which is a lot higher than what it was for linear regression. Now again, we don't need all these decimals, so I'm going to round my a value to negative 0.008, and then my b value to 0.74, and c I'm just going to leave as 16. So my equation is negative 0.008 times x squared plus 0.74 times x plus 16. So now the last one I'm going to do is a exponential regression. So we'll go scroll down, and that's option 0 here, the exponential regression. Again, same inputs as last time. So we'll go ahead and go down to calculate, and it'll give us our equation here. So our equation is 29.8, because I'm just going to take this part, times 0.999. I'm going to leave this as 0.99, not round it up to 1. I'll show you why here in a minute. And then all raised to the x value, x power. And we have our correlations. Our r is 0.04 with an r squared of 0.0016. So these are pretty weak correlations, except for the quadratic regression. That one had a very strong r squared. So we expect that one to best predict our values, but we're going to go ahead and plot it to see. So in my y equals, I'm going to put in my three equations. So my linear one first, that's negative. That's not the symbol for negative, it's that one. 0.006 times x plus 29 0.9. Then we'll go down to y2. I'm going to put in my equation for the exponential equation, or the quadratic equation, not the exponential one, plus 16. And then this one, this is the one I'm going to put in my exponential equation. Now the reason I left this as 0.999 and not rounded up to 1 is that if it's 1, it's just going to be a linear graph. It's just going to be a horizontal line. It's not going to show any variation. So by leaving this as 0.999, I'll force the equation to graph it. So now I'm going to go ahead and turn on my scatter plot. So I'm going to do second y equals to get to my stat plot option. I'm going to go ahead and choose stat plot 1 and turn it on. Now I want it to be a scatter plot, so I'm going to leave this option. L1 is where my x variables are. L2 is where my y variables are. And I'm going to just leave everything else the same. Now if I press graph, it's going to show me the lines, but nothing else. That's actually only going to show me one of the lines. That's because my window, I'm not showing my data yet. So I'm going to need to adjust my window, so I'm going to hit window. Now my smallest value for my explanatory variable is 15. So I'm going to choose a smaller value. I'm going to choose 10. Now there's nothing important about this 10. It's just smaller than 15. Now my biggest value is 75. So I'm going to pick something bigger. I'm going to pick 80. So that, again, just needs something bigger. Now my lowest y value looks to be about 24.4. Yep, this one right here. So I'm going to choose something smaller. I'm just going to choose 20. And my biggest one looks to be 32.4. So I'm going to go ahead and pick something bigger than that. I'm going to go ahead and pick 35. Again, just something bigger than my biggest value and smaller than my smallest value. The x scale, the y scale, the x resolution, the delta x, and the trace step, just leave those in your default settings, or it'll calculate what it needs. So now if I hit graph, now we can see my data is the scatter plot. This blue line is my linear regression, and my black line is my exponential regression. So again, if I just rounded it off to 1, which I'll do here in a second, so I'll go ahead and do that now. So if I change this to 29.8 times 1 to the x, it should just come in as a horizontal line. So you will see the purple line, and there it is. Yep, it's a horizontal line. So that's why I made it to be the 0.999 instead of rounding it to 1, so I would get some variation here. Now if we look here, we do see that the red equation is the one best modeling the data, because our blue line, which you can't really see, so I'm going to delete my magenta line because I don't want it anymore. So the blue line, that's our linear regression. It goes through the middle, but it doesn't show that it went up here or that it's going down on the ends. Same with my exponential, but my quadratic is showing it the best. So this data is best modeled with a quadratic regression equation.